In this illustration, we'll study about a rectilinear motion with deceleration. Here we are given that a particle moves rectilinearly with deceleration whose magnitude depends on velocity v of particle as a is equals to k root v, where k is a positive constant and at t equal to 0 the velocity of particle is v naught. This is the initial speed, and we are required to find the total distance traveled by the particle before it stops and total time of motion. Here we can see it is a non-uniform retardation. So in this case we need to use calculus. So here we can write during motion of particle as a is given as minus k root v. Here I have used a negative sign because we are given that it is deceleration. So we can further substitute a as v dv by dx is equals to minus k root v, and this can be written as root v dv is equals to minus k dx. Further, if we integrate this expression with that x equals to 0, the speed was v naught, we are already given the initial speed, and after covering a distance x, the speed becomes 0. So this x will be the total distance covered by the particle during its motion. So on left hand side here we can write the integration will be 2 by 3 v to power 3 by 2, and we put the limits from v naught to 0, and on right hand side we are getting it as minus kx. So here this minus can be eliminated and we substitute the lower limit. So this 2 by 3 v naught to power 3 by 2 is kx. This can also be written as xt, total distance traveled. So here directly the total distance traveled we are getting is 2 v naught to power 3 by 2 divided by 3k. That is one result of this problem, the total distance traveled by the particle before it comes to rest. Similarly, we can proceed further here. Again, we can write a as minus k root v, and now we can substitute a as dv by dt as we are required to find the total time of motion. This again minus k root v, and further we can write dv by root v is equals to minus k dt. If we integrate this expression at t equals to 0, the speed of particle was v naught. And if total time the particle is in motion is t, then the final speed becomes 0. So if we integrate this 2 root v, and we put the limit from v naught to 0, and this equals to minus kt. Again this negative sign can be used in reversal of limits, and we can write it as 2 root v naught is equals to kt. Or the total time of motion here we can write as 2 root v naught by k. That is another result of the problem, the total time of motion before the particle stops.